Olisani, you may begin.
Thank you. Morning, grade 9s. Hoping you are well, rested and ready for your natural sciences class today. I am still your host, Olisani Mbata. You can find me on Twitter at MbataX, or you can find me on Instagram at XKIM. I am quite aware that some of you were not aware of the new way of coming in. You need to actually subscribe. Remember, subscription is free. It is for your own good to be actually admitted to class so that you can actually be safe inside the classroom. So I did try to actually tell others on my Instagram and Twitter to actually come in. So I see some a bit late, but that will not stop us from starting. Remember that Unkabezi, welcome Unkabezi, welcome Unkabezi, and then and I saw James just came in, Sia, Lynn, and all others. Thank you for joining us. So remember that yesterday we had a homework. I would Shama, hello Shama. Remember that yesterday we had a homework, so I want us to actually continue with our homework. But before we continue with our homework, today we are going to learn this just after our homework. We are going to learn reactions of acids with metal carbonates. You're going to learn about metal carbonates, and then you also need to learn the application of acids, base reaction of acids with metals, and you're also going to do how do we test for hydrogen from substances to see that we've got hydrogen. We are going to see that. And then grade 9s, I've got good news before we can start with our corrections. The good news is on Friday, we will be writing a test for 45 minutes, in fact 30 minutes duration, and then 15 minutes. I'll obviously be assisting on how to send your answers in. I'm ready to mark your work. It's chemistry test on Friday, so please tell the others Friday lesson is about test. So you'll be writing your test and then you'll forward them to me. I'll print and mark your work and send it back to you. Okay, then let us look at this homework correction from yesterday. So yesterday we did the hydroxide. Remember, we're doing reactions of acids and bases. And yesterday we agreed that, or we learned that when acids and bases are reacting, they react against each other. And then we also discussed the general equation. Acid reacting with base or base reacting with acid, the product is salt and water. It's salt and water. So what happened is, now we are going to do, I'm going to do number 1 while everyone else is getting ready to assist me with other corrections. So what's going to happen is I'm doing number 1, and then number 1, sodium hydroxide is reacting with nitric acid or nitric acid, and then the product, or the we're going to get salt and water. The type of salt is determined by the reactants, remember. Then now sodium hydroxide is reacting with nitric acid, so it's NaOH is reacting with nitric acid, So how do you represent nitric acid? Nitric acid is HNO3. HNO3. That's a nitric acid. What do we get? We get the type of salt is sodium nitrate. The type of salt that we get is a sodium nitrate plus water. You know now from the general equation. Remember. So now we need to balance. I've been preaching to you grade 9s that you need to balance after this. I'm hoping those who did the homework are marking their work. Please, if you want to work with me, please type on the chat box and my producer is going to see that, and then we work together for number 2. We've got sodium hydroxide reacting with nitric acid, and then we get sodium nitrate plus water. So this is salt, sodium nitrate plus water. So now, is the equation balanced? Let us calculate our elements or atoms here. So we've got 1 sodium on the left and 1 sodium on the right. It's 1 and 4 and 3, so it's 4 oxygen atoms, and we still have 4 on the left. And then hydrogens, it's 1 and 2 here, and then we still have 2 hydrogens on the right. Then we can actually say our equation is balanced. Any questions, grade 9? Raise up your hand. If you've got any question, raise up your hand with number 1. Did you get the same answer? Did you get the same answer, grade 9? If you got the same answer like as mine, raise up your hand. Grade 9s. Thank you, James. I see you got the same answer with me. Unkabeti got the same answer. Everybody got the same answer. Thank you so much. Yeah, I can see most of you did. Okay. So now, thank you. Let's stop raising hands, and I want someone who wants to do number 2 with me. Oh, Bongi. I see Bongi wants to do number 2 with me. Can her mic be opened? Can Bongi's mic be opened? Is Bongi's mic open? Hello, Bongi. Bongi. Bongi, are you there? Okay. Who is there to do number 2 with me? Calcium hydroxide reacts with hydrochloric acid. Who wants to do it with me? Raise up your hand so we can open your mic. Please open someone's mic. 2 participants raise their hands. Anyone? Hello? Hello?
Hello.
How's it?
There are many mics open.
Open CA's one. CAI. Hello?
It's open.
Hello? Okay, let's wait for them. Hello? Who's there? Hello? Who wants to work with me doing number 2? Hi, Nkabeti, how are you?
I'm good, and you, sir?
Okay, raise up your voice because we're working with a lot of them. So we've got calcium hydroxide reacting with hydrochloric acid. So we need to actually now write it in a simple equation. So please give me calcium hydroxide.
It's HCI.
Oh, no, let's start with calcium hydroxide, the base.
HCS.
Calcium hydroxide.
Says it not.
There we go. CaOH, and then we close the bracket, and then we've got a 2 there.
Oh.
And then
HCI.
HCl, hydrochloric acid, right?
Oh.
Yes, and then
Yes,
what do
sir.
we get? What do we get, Unkabit? The type of salts that are going.
CaCl.
Calcium chloride, yes.
CaCl2 plus H2O.
Plus H2O, ne? Then now, Unkabiti, is our equation balanced?
No, sir.
We're gonna work in balancing it just now. Give me a minute, a second actually. So where do we start now? We need to balance it because we both see that it is not balanced. Where do we start?
The H2O and we start with the hydrogen.
The hydrogens are not balancing. How many hydrogens do we have on the right? There are 2. On the left,
2.
on the left, how many?
3.
3. So how are we going to balance it now?
Times.
So we're going to put a coefficient 2 here. Then we have 4 hydrogens on the left, and we have 2, 3 this side, so they're still not balancing. Let us put
We're gonna put coefficient 2 again.
and then let's calculate how many do we have. So it's 4.
So it's balanced now.
It's balanced, but we need to calculate because let's look at our chlorine as well. So now how many chlorines do we have on the left?
So,
And then on the right, we've got 2, 2.
yes.
You see that, right?
Yes, sir.
Yes, that's how we balance it, grade 9. We count each and every other element. Thank you so much, Unkabeti. Let me get another one so we go to number 3. Thank you so much. Hello, grade 9? Who's there? Do we have someone there? Chidu. Chidu, open your mic. Let's work. Hello, Chidu.
Hello,
Chidu,
sir.
how
Hello,
are
sir.
you?
I'm good, thanks, and yourself?
I'm good. So I've already done magnesium hydroxide and sulfuric acid for you. So
Yes, sir.
magnesium oxide, magnesium hydroxide reacting with sulfuric acid, we're getting magnesium sulfate and H2O. So my question to you, Chidu, is the equation balanced there?
No, sir. Wait. It looks balanced, sir.
Let's calculate. It is not balanced. Let's calculate. Let's start with oxygen. How many oxygens do we have on the left? 4.
Yes. Oh, 4.
We've got 4 oxygens and 2 oxygens this side. So that means on the left, you've got 6.
6.
And then on the left, calculate your oxygens. It's 4 and 1. So we've got 5. So then we know already that it is not balanced. But if we put a coefficient 2 here, is it going to be balanced? Let's calculate. We've got 2 oxygens and 4, it's 6. This side we've got 4 and 2, they are balanced, it's 6. Let us look at our hydrogens. It's 2, 2, it's 4. And then this side it's also 4. And then it's SO4, SO4, and then magnesium and magnesium. So our equation is now balanced. Did you see that?
Yes, sir.
And then before you go, let us also do potassium hydroxide and hydrochloric acid. So
Yes, sir.
look at this equation. Is it balanced?
No, sir.
What is not balanced there?
There's 2 hydrogens. Oh wait,
Where?
there's also 2 on the other side. Never mind. Yes, sir, it's balanced.
The equation is balanced, you see? So we've got 2 hydrogens on the left and 2 hydrogens on the right, 1 oxygen on the left, on the right, and 1 oxygen on the left, oxygen on the left, potassium, potassium, chlorine, chlorine, and then we are balanced. Thank you so much, Chidu. Let me see who else is there. Who is there? Who wants to do aluminum hydroxide with me? Anybody, raise your hand, we open the mic. Let us do aluminum hydroxide, grade 9. Who is there? James, you are in the class. Are you there, James? James. Lynn, are you not ready to do this one with me? Who is there? Who's ready to do aluminum hydroxide reacting with hydrochloric acid? Grade 9, let us work. Who is there? Okay, I'm going to do it by myself then. Nkosi, where is Nkosi? Is Nkosi in the class today? Okay. Aluminum hydroxide, it's Al OH reacting with HCl. All right. Aluminum hydroxide. What do we get? What did you write grade 9? You getting? What do you get grade 9? I can't be working alone. I've got people in my class. So I want to know, what did you write? Huh? So you're gonna get aluminum chloride and water. Are we clear?
They can open their mics.
Why are they not opening? Grade 9s, be in class. So we get,
So I don't understand how to do this.
why?
Yeah, sir.
Like, I don't know, like,
So
how
I
do you,
think it's AlCl,
AlCl,
Cl plus H2O.
okay. It's aluminum hydroxide. I want you to participate, grade 9s, because if you do not participate, then you won't know how to do it, and then you will fail your test on Friday, and I will be disappointed because I want you to pass. So we've got aluminum hydroxide.
Yes.
Are we clear?
Yes.
And it's reacting with hydrochloric acid. So I wanted us to actually say, what do we get? So aluminum hydroxide, we're gonna get aluminum chloride. Someone said that we get aluminum chloride, Al.
Cl3.
Cl what?
Three.
Cl3, and then we got, over I see everyone knows, is H2O. So we need to balance our, who am I working with?
Unkabit.
Oh, Unkabit. So there we go. We have to balance now, Unkabiti. Oops.
It's not balanced.
It's not balanced. We need to balance it. So now let's calculate what is not balanced there. So firstly, our oxygen.
Hydrogen.
Let's start with our oxygens. How many oxygens do we have on the left?
One.
On the left?
it's 3.
3, yes.
Oh, three, sir. 3.
And then on the left, on the right? 1.
1.
And then we want to actually say, okay, let's put the coefficient here, 3.
3.
Then we've got 3 oxygens and 3 oxygens on the left. Let's look at our hydrogens. How many hydrogens do we have on the left?
4.
4. And how many do we have on the right?
2.
Guys, no. We've got 6. 3,
6.
coefficient 3 multiplied by subscript 2 is 6. Are we clear? Are you following, Unkavit? And the rest?
Sir.
Yes,
So
sir.
we need, so if we've got 3 this side, how many hydrogens are we going to need this side? Let's continue and see. So let us put,
We're gonna need 3 more.
we're gonna need 3 more, ne? But let's look, how many chlorines do we have on the left and how many do we have on the right? So we've got 3.
3 on the right and
The left.
1.
We've got 1 on the left, right?
Yes, sir.
And then we've got 1 on the right. 3 on the right, I'm sorry.
You
So
just have to put 3.
okay, grade 9s. Let us look at aluminum first. How many aluminums do we have on the left?
1.
Huh?
One. One aluminium.
One on the left and one on the right. Let us look
Yes.
at chlorine. We've got one on the, what you call,
Left.
one on the
Left.
left and 3 on the right.
Yes, sir.
So let us put a coefficient 3 here. Can you see that?
Yes, sir.
So now, do you think the equation is balanced now?
Yes. Wait. Yes, sir, it is.
Is the equation balanced, grade 9?
Yes.
Yes, sir.
Sir.
Yes, it is balanced now, grade 9. We've got 3 chlorine and 3 chlorine on the left, 1 aluminum, 1 aluminum. We've got 3 hydrogens and 3 hydrogens, which is 6, right? And then I
Yes.
said 3 multiply by
2
2,
equals 6.
it equals 6, right?
Yes, sir.
And then I want you to write that down, grade 9, and it will be there on what you call, it will be there in your test, this one. So you need to know it. Any questions, grade 9? Anyone who wants to ask any question?
Sir,
Yes.
you see, how do you get the right hand side of the that? How do you get the right
Okay.
hand side?
Remember, we said these are hydroxide, so the bases are reacting with they are reacting with acids here, right? So I
Yes, sir.
said the general equation to you, grade 9, is a base, right,
Yes, sir.
reacting with acid. We get a salt and water. That's a general equation. So now the reactants will give us these, whatever is on the left. Let me highlight it with red. Whatever is on the left, we call it the reactants. So the reactants, this reaction, the red reaction, gives us this on the right, gives us the products on the right.
Yes, sir.
Do you understand, grade 9?
Yes, sir.
Yes, that's how we do it. So in your test Friday, what I'm going to do on Friday when I'm giving you the test, you are going to write the test. Remember, I've been saying define the following terms. So I will say to you on Friday, give the correct scientific term. You need to know that. Then question 2 or question 3, it will be the reaction of acids and bases. Are you clear?
Yes, sir.
So now you need to know these reactions, but if you do not know this basic chemical equation, the general equation where a base react with acid and then you get salt and water, you will not be able to see it. Remember, I also told you when a metal reacts with oxygen, we get metal oxides. When a non-metal reacts with a, what you call, an oxygen, we get non-metal oxides. So now we moved to acids reacting with bases where we get salt and water. So today I want us to continue to, let us continue to our today's lesson. So our today's lesson, we are here, reactions of acids with metal carbonates. Are we clear? So now, grade 9s, you know what are acids. Are we clear? So today, that means you are going to know a metal carbonate. So a metal carbonate is any metal that is bonded together or forms a compound with a metal carbonate. So a metal carbonate, or with a carbonate, I'm sorry, with a carbonate. A carbonate is a carbon that is bonded with 3 oxygen atoms. So we can have a copper carbonate, we can have anything, we can have, looking at your periodic table there, looking at the metals, we can have a manganese carbonate, we can have a zinc carbonate, we can have aluminum carbonate, we can have a number of carbonates. Are we clear on that one, grade 9? So they say to you a carbonate ion consists of a carbon atom and 3 oxygen atoms bonded together, and then we call that a carbonate. Then the formula for carbonate is CO subscript 3. We've got metal carbonates, which are bases. So you're going to have a metal carbonate reacting with acid. So you already know that they are reacting against each other. And then they have the ability to make acids less acidic. Most carbonates are not soluble in water, or they are only soluble partially. So they do not dissolve completely in water. So the synonym for soluble is dissolving. So yes, when an acid reacts with a metal carbonate, the products are salt, water, and carbon dioxide. I want you to actually see this. I'm going to highlight it. We get to have salt. We're gonna have water. We're gonna have water. We're gonna have carbon dioxide. Can you see the difference with these reactions, grade 9? Who wants to tell me the difference from the metal oxides and the reactions of hydroxides and acids, and then the reaction of metal carbonates and acids now? Can you see the difference? So when a metal reacts with oxygen, we get a metal oxide. We've moved on now. We said when an acid reacts with a base, which mostly are hydroxides, the products there, it will be salt and water. Then now we have metal carbonates reacting with acids. We're getting salt, water, and carbon dioxide. We first got one product, we moved on to get 2 products, and then now we are getting 3 products. Are you following, grade 9? Anyone who wants a clarification with something? Anyone? Grade 9? Anyone who wants a clarification? So you are all understanding.
Yes, sir.
Let us move on. So the type of salt that forms depends on the acid and the metal carbonate that are used in a reaction. Please write this one down, please. The general weight equation for a metal carbonate. You have a general weight equation for metal oxides. You have a general weight equation for a base and an acid. Then now you are looking at a metal carbonate, which is also a base, but it's a carbonate base. We had a hydroxide bases that side, and then now we have a carbonate base, and then there it is. A metal carbonate reacts with acid to give us salt, water, and carbon dioxide. So your only duty when you see a metal carbonate is to find salt. But what follows? Water, we all know, water is H2O. Carbon dioxide, we all know, CO2, or you can say CO subscript 2. And then H subscript 2O, that's water. And then the type of salt that is going to form, it actually depends on the acid and metal carbonates that are reacting. So let us look at the example for carbonate and acid. Do I have an example for you, grade 9s? I must have an example for my grade 9s. There we go. We have a weight equation. Calcium carbonate reacts with hydrochloric acid to form calcium chloride plus water and plus carbon dioxide. Are we clear? The simple equation, we have calcium carbonate, CaCO subscript 2 plus hydrochloric acid, then which is HCl, and our salt is calcium chloride and water and carbon dioxide. Then now let us, the equation is not balanced. Let me balance it for you. Then we had calcium and calcium. The carbonate group is no longer there this side, so we need to actually now balance that. Let's see. We've got one calcium, one chlorine, and two chlorine. We've got two hydrogens on the left, on the right, I'm sorry, and we have one on the right. And then we've got oxygens. How many oxygens do we have on the right? On the left, we've got 3. On the left, we've got 1 and 2. So they are balancing. So let us put a subscript 2 here. If we put a subscript 2 here, for chlorine and hydrogen, let us see if everything balances. Yes, it does balance. We've got 2 chlorine on the left and 2 chlorine on the right. We've got 2 hydrogens on the left and 2 hydrogens on the right. So our equation is balanced. Any questions, grade 9? Do you have any questions right now? There are no questions. Let us continue if we do not have questions. If we do not have questions, let me see if I've got something else that I can do with someone. Well, magnesium carbonate reacts with sulfuric acid, and we're getting magnesium sulfate, water, and carbon dioxide. Then we all know that magnesium sulfate is a salt. Magnesium sulfate is a salt. So sulfuric acid, you all know this. The equation for sulfuric acid is H2SO4. So you need to know your acids as well, because in a test, I'm not going to give you these compounds here, the acids. I will say a certain group reacts with sulfuric acid. You should know that sulfuric acid is H2SO4. You should know that nitric acid is HNO3. You should know that hydrochloric acid is HCl. You need to know that. Then now magnesium carbonate reacts with sulfuric acid. We're getting magnesium sulfate plus water plus carbon dioxide, and the equation is balanced. You can calculate and you'll see that it is balanced. I will move on. Then as I'm moving on, I want you to see this. Again, sodium carbonate reacting with nitric acid, we get sodium nitrate and water plus carbon dioxide. There we go. Sodium carbonate is Na2CO3 plus HNO3, which is nitric acid. We're getting sodium nitrate, which is NaNO3 plus water plus carbon dioxide. The equation is not balanced there, and then I balanced it for you, as you can see. As you can see, that's what we did. That's how we balanced the equation. I want you to know, to ask me any questions for the test. Do you have any questions? Grade 9s, are you understanding how the carbonates work and how hydroxides, how do hydroxides also work? Can you see the difference between carbonates and hydroxides? Who can tell me the difference between the hydroxides and the carbonates? Anybody in the class who wants to tell me the difference? Grade 9s? I don't want to be alone. The class is so lonely today. Why? Why is everyone quiet? How to test for carbon dioxide, grade 9th? So how do we test for carbon dioxide gas? You already know the chemical formula for carbon dioxide, which is CO2, one carbon atom with two oxygen atoms. So carbon dioxide has no color or smell. If you want to know whether the carbon dioxide gas was formed in a reaction, you first need to trap it. LaMotta is a solution of calcium hydroxide, CaOH. If you filter the lime water so that it is clear, you can use it to test for carbon dioxide. Carbon dioxide reacts with clear lime water and turns it milky. In grade 10, you will learn why this happens. So bicarbonate of soda, so this is an application. Bicarbonate of soda, it's HCO3, is used for baking. So we normally call it baking powder. So it's a bicarbonate of soda. When it is heated and reacts with other ingredients, CO2 gas is released. This makes the bread or cake rise. So I know that most people think CO2 smells ugly, but CO2 doesn't have any smell. Only smell that you smell is because of the reaction that the gas, CO2 gas, was reacting with, and then you'll get your fart, you'll get when you're baking, and then the CO2 reacts with vanilla, and then you get this magnificent smell. Excess stomach acid causes indigestion and heartburn. Antacids are used to neutralize excess stomach acids. Different antacids contain different bases, e.g. CaCO3, which is calcium carbonate, magnesium carbonate, magnesium hydroxide, and aluminum hydroxide are all those used for indigestion. When an insect bites you, it injects a small amount of a chemical into your skin. This is why it stings. Bees inject an acid. A bee sting can be neutralized using a base such as a bicarbonate of soda or a weak acid such as vinegar. So if someone is bitten by a bee, and then to take the acid out, remember that we said acids and bases are work against each other. So if you've got a bee sting, you can take a baking powder or a bicarbonate of soda, put it in water, and then rub it there. It will obviously decrease the acid because it makes acid less acidic, right? That's what we said. So you can put it there, and then the person will have less pain. Or you can take a weak acid such as vinegar, and then you put it there where there's a bee sting, and then when you rub or lotion with the vinegar there, the person will obviously feel less pain because it will making an acid less acidic. We also know of toothpaste as our base. Our toothpaste is also a base. So reactions of acids with metals, we know that about density, amount of mass in a given volume of a material. When a metal reacts with an acid, the products formed are salt and hydrogen gas. You see now, we're going to another, our fourth reaction. We've got nonmetals and metals reacting with oxygen, where we're getting oxides. We've got what you call acids and bases. We get salt and water, and then we've got carbonates. Then when the carbonates are reacting with acids, we're getting salt, water, and carbon dioxide. Then now we've got acids reacting with metals. So you know your metals, you get them from your periodic table. So now there's a general weight equation. So you must know these four general weight equations by the end of today. So the general weight equation there is metal reacting with acid, you're getting salt and hydrogen. You're getting salt and hydrogen. So you will write saying acids with metals, you write that general weight equation. Carbonates and acids, you write the weight equation. Hydroxides with acid, you write the weight equation. For metals and non-metals, you write weight equation. So for non-metals and metals, we always get oxides. It's going to be either a metal oxide or a non-metal oxide. And it's grade 9. Thank you very much. So you know this word equation of acids and metals. Let's look at the example. Magnesium, which is a metal, reacts with hydrochloric acid to give us magnesium chloride plus hydrogen. There's an unbalanced equation. Mg plus HCl gives us MgCl2, which is a subscript 2, plus H2, which is hydrogen. Remember that chlorine, hydrogen, oxygen, and others, there are only 7 of them. And I said the sentence to remember diatomic molecules is never be never be afraid of ice cold beer, or never be scared of ice cold beer. Then those will be your actually diatomic molecules. You remember that. So now look at zinc. When it reacts with sulfuric acid, there you get zinc sulfate, which is salt, and then you also get hydrogen. There it is, the symbol equation. Zinc reacting with sulfuric acid, we're getting zinc sulfate and hydrogen. And you can see that one comes already, it comes already, it comes already balanced. James, you keep on going in and out. What's wrong, my boy? Is it the network? Yeah, James. James keeps going in and out of the classroom. I want you to look at this. When we've got copper reacting with nitric acid as well, you're gonna get copper nitrate, which is salt, plus hydrogen. There is the simple equation, the balanced and the unbalanced word equation of copper. You've got one copper reacting with a nitric acid, which is HNO3, and then you get a copper nitrate. So a nitrate group is obviously nitrogen that bonds to 3 oxygen atoms, and then you get a nitrate. And then a carbonate is obviously a carbonate. We said a carbonate is whatever metal with C with a carbon that is bonded to 3 oxygen atoms as well. So now we've got a copper nitrate there reacting
Hi, Kolisani.
So I can't hear anything. Network yaka. So
Hi, grade 9s. Yeah, your teacher will be back just now. We're trying to sort that out.